Okay, this is a second video on preparation of amines. And all of the examples we're going to see in this video are substitution reactions. So amines are good nucleophiles, and ammonia will readily undergo an SN2 reaction with an alkyl halide. In this example, we're looking at ammonia reacting with methyl iodide, and we get this SN2 reaction where the ammonia replaces the iodine, which is our leaving group. This gives us an ammonium ion, and then the ammonia that's present will act as a base to deprotonate my ammonium ion to give me a primary amine. Now it turns out this is a great method for making quaternary ammonium salts. A quaternary ammonium salt is where the nitrogen is attached to 4 different alkyl groups. It's not such a great method for making primary amines, and so let's go to the next slide to see why that is. So we've made the primary amine on the previous slide. Ammonia is a good nucleophile, but when I put an electron donating group on the nitrogen, that makes the resulting primary amine an even better nucleophile than the ammonia that we started with. So if the ammonia was going to be willing to undergo an SN2 reaction, the primary amine that we made is going to be even more willing to undergo an SN2 reaction. So we're going to put a second methyl group on. Then the ammonia will come in and deprotonate it to give us our secondary amine. Well, if the primary amine was a good nucleophile, the secondary amine with 2 electron donating groups is an even better nucleophile. And so we're going to put on 3 alkyl groups to give us a tertiary amine. And again, if the secondary amine was a good nucleophile, the tertiary amine is an even better nucleophile. And so that's how we're going to end up with this quaternary ammonium salt. Now, the problem is, even using stoichiometry, it's difficult to just stop at the primary amine, and we're likely to get a mixture of products, which we generally don't like in synthesis. So alkylation of ammonia, great for making quaternary ammonium salts. But let's switch to some other methods that we can more reliably get primary amines. So the first way we're going to talk about is called azide synthesis. And so N3- is an azide ion. So if I react an alkyl halide with sodium azide, that will replace the halogen with this N3- ion. I can then reduce that either using lithium aluminum hydride or hydrogen gas with a platinum catalyst to go from the azide to the amine. And so this is a better, more reliable method for making a primary amine than trying to do it through monoalkylation of ammonia, which is hard to control. Here's the mechanism for azide synthesis. I'm not going to make you responsible for this, so if you would like to pause it and look at it more carefully, you're welcome to, or you can find it in your textbook, but I'm going to continue on. The second method for making primary amines is called Gabriel Synthesis. And so this is another way to make primary amines, and we do that by using phthalimide. And so here's phthalimide. What we do in this synthesis is first convert phthalimide into an anion by reacting it with a strong base like potassium hydroxide. And so that'll give us potassium phthalimide with the potassium just acting as a counterion. I can then alkylate the potassium phthalimide through an SN2 reaction by reacting it with a alkyl halide. And so that'll put an R group onto the nitrogen. And then the last step is we're going to release the amine that I've created here from the rest of the phthalimide molecule. And so we can do that either using acid to hydrolyze it, but it turns out that process is relatively slow. So a common alternative is to react this with hydrazine. And so what happens in either case is this amine, or the nitrogen from the phthalimide, plus the alkyl group from the alkyl halide will essentially get chopped out of the rest of the phthalimide molecule, and then the bonds where the nitrogen was attached to the rest of the molecule are replaced by hydrogens. So this is another way to create a primary amine from an alkyl halide. All right, and so what would this look like if we were using this in synthesis? How would we put it all together? So I'd start with this phthalimide molecule, turn it into the anion by reacting it with potassium hydroxide, then react it with an alkyl halide, where the halide is where I want the amine to end up, and then use hydrazine to release the amine from the rest of the phthalimide molecule. Okay, so I want to finish this up with an example. So I want to see how I would make the following compound using the Gabriel synthesis. So to do this, I want to start with the phthalimide. And then I'm going to use potassium hydroxide to make the anion. Then I want to react that with the alkyl halide, where the halogen is where I want the amine group to end up. So the alkyl halide I would want to use in this case is that. And then finally, I'd want to use hydrazine to give me my final product, to release the amine. And that would give us our final product.